Thank you, Mr. Chairman. Good morning, everyone. The International Genomic Partnership, or IGNOP, as many of you will be aware, is the international project for collection, storage and sharing of genotype data, for which Ireland is also a member. So I'm going to talk to you this morning about the systems which we've implemented here in Ireland for allowing us to manage this process. So back in 2009, it became obvious that there would be a need to devise some sort of a system to manage and share the genotype data that we were receiving both from our national programs and from our international sharing projects. So our starting point was to look at the data we'd received from the genotype labs, the combination of text files, CSV files, image files. So we held a number of conference calls with IGNOP members to discuss our ideas and also to get their views on what they were currently using and some of the proposals that we had put forward. So it's very useful, and we were able to gather lots of different information from that process. We also contacted some other organisations such as the Sanger Institute in the UK, who have quite a lot of experience in the storage of genotype data for humans. So our aim basically was to develop a system that was scalable, flexible, and allow the resource of the database to be utilised and allow for the design to be implemented by anybody who has a database resource. So the first thing we had to do is we had to set a standard for the files and for allowing us to input and output those files. So the standard is pretty generic, one or two mandatory fields such as the animal identifier, etc. So to have a quick look at the process for which we go through for the loading of the genotypes, the genotype files are uploaded to our secure server. Then an automated process runs on the system which uncompresses and inspects the files. So as part of this then, it looks at the files and makes sure that the file names are in the correct format, etc. The next thing it does is we have a database utility which loads the files to a staging table. And as part of that then, we have an identification process and a quality assurance check. The identification process is probably the most critical part of the process, where it goes and checks that the incoming animal identifier is in a format that can be recognized internationally. So if it's not, a conversion is done to the Interpol identification number for that animal. So then the next thing that happens is the validation of the entries are loaded to the genotype database, and the invalid entries are flagged and reported for subsequent viewing by people later on through the error reporting process. So as part of the loading process then, the individual genotype files are actually created, compressed, and are loaded as text files into the database in a mechanism known as a blob, or a binary large object. So in the incoming files we get from the lab, we can get a number of maybe 90, 100, 200 animals in the one file. So we take each of those and we split them out individual animal files in order to make the retrieval of the details later on quick and efficient, rather than have to search through a file with hundreds of animals in it. As part of the loading process also, the genotype details are loaded in rows and columns into the database. So we now have them in both a binary lob, and we also have them in rows and columns. We also perform a parentage SNP extraction process where we have identified certain parentage SNPs that we're interested in, typically 116 to 120 SNPs, and those are extracted again into a separate table, again for quick retrieval later on. The call rate checks that are performed are in the relation to the quality of the calls for the genotypes. Typically in Ireland, it's anything greater than 0.9 is used, anything else is excluded from any extracts or for display purposes. The final part of the step then is the parentage verification step, which takes the parentage and does a validation where possible for the parentage. So just again, some information there, typical kind of file types, file names, etc. So the files, again, we can have a quick look here at the typical files. The first set there are the actual genotype files with the SNPs, the allele1 forward, allele2 forward, etc. Your second set there is the actual summary file, which contains the call rate information, etc. And the third one is the SNP map file, which contains information such as the Centrix position, which is the unique identifier for the actual the chip itself. So to give you a little bit of a breakdown and history of what we have in ICBF, currently we have about 2,300 3K chips. We have just over 7,000 of the LDs loaded into the process. We have another 7,000 of the 50Ks, and we have about 2,600 of the high-definition chips, all loaded into the database. That translates then in something like 21,000 summary files for genotypes. It gives us 21,000 of those raw text files. We also have the parentage table containing the parentage SNPs, which is about 2.7 million. And then the SNP data, which is the rows and columns for the actual genotype data, we have just over 2 billion records in that table currently for the data. Okay. And just to maybe again give you a little feel for the size of the files that come in, typically the file size for 96 LDs is about 45 megabytes, going to 3 gigs for 48 HT files incoming. So they're processed through the database system. So to give you an idea of how that actual process takes place and the performance for which we've managed to achieve, initially when we started off, we developed a Perl script for the loading of the genotype data from the raw text files. However, we've refined this process using the database and using Oracle external procedures and PL SQL. So what was taking about 1.6 hours to load 96 LDs now takes between 5 and 10 minutes, depending on the load on the box, to load the details. For 48 50Ks, it was about 2.5 hours. It now takes, again, between 5 and 10 minutes to load the details. And the HDs, which are obviously quite a bit significantly bigger, 48 HDs was taking about 48 hours, now takes just under 2 hours to load the data. This Perl script was running on a Red Hat implementation 64-bit machine with quad-core 64 gigs of RAM, while the Oracle database, it's an Oracle 10G Release 2 enterprise database. There's about 1 terabyte of storage allocated to the database currently, and that's running on basically a 650 megahertz 8 gigs of RAM machine. So this gives you a feel for the difference between running through the Perl script and running using the Oracle database. So now that we have the data loaded into our database, we've also provided a portal for access to the data and for allowing people to log in and access that data on our database. And again, IGNOP members have access to our database if they so wish to go and extract information from it. So typically a user can log in and they're presented with the homepage, which gives them a number of options. First option we'll have a quick look at is the individual animal search. So the individual animal search allows a user to come along and to type in an animal number and go and retrieve any information that's in the database for that animal. So typically, you'll see information in relation to the animal's number, the animal's name, the breed, the owner of the animal. Typically, other information such as the call rate, which is important, the chips that are available, and whether we have the full genotype or just the parentage SNPs available to us. So by typing in that information, you will be able to retrieve the information for that animal and what's actually on the database. Also, as part of the process, it does a validation against your access level to see whether you have full access or parentage access or no access at all. But in either case, it will still return the information for you in relation to the animal, so you can see that the animal does exist, and we just may not have access to it at this moment in time. Another option, which is probably going to be quite useful to people, is the option to be able to do some sort of an advanced search, which allows you to come along and search based on a number of different criteria. So information such as maybe you want to search on particular sire or dam information, a particular breed, maybe information in relation to the age of the animal, the sex of the animal. Or in this case, what we've chosen here is that we're looking for female animals that have been done on the low-density chip for Holstein. And you also have the option to decide on the bottom right here as to whether it's the full genotype you're looking for or the parentage, and again, how you want to retrieve that data, whether it be in a single file or in individual animal files. So once you've run the retrieval, it will bring back all the valid animals that meet that criteria, and you can select any that you so wish, and then retrieve those animals. A third option is the option to be able to actually come along and to present a CSV file to the system. So you just have a list of animals that you'd like to check against the database. So you just upload that CSV file of animal tags. Again, as long as the tags are of an international format, the system will then validate them, verify, and return access to you as to any of the animals that you have access. At all stages, the retrieval process runs in the background, and it takes the extraction from the database and uploads it to the secure FTP server again, for which you have access, and then you just download the relevant files as part of that process. So as I say, as part of the extraction process, again, it's extracted via the Oracle database using some Oracle procedures, and it goes to the secure FTP directory. And as part of the extraction, all the permissions are checked, and you're presented with 3 files, being the genotype file, the summary file, and the parentage file. So typically the genotype file are all the genotypes, the summary is the information such as the call rates and other pieces of information which might be useful in having a quick look at the summary. And then the parentage file. So again, we actually extract the parentage chips as part of the process so that people don't have to do that if they are only interested in the parentage for those animals at a later stage. So to give again maybe a quick look at the execution times for the extraction process, typically 100 low-density chips can be extracted in approximately 10 seconds. The 50K 100 chips can be extracted in about 20 seconds. And to extract 10 HDs takes about 35 seconds. So again, obviously the HDs are that significantly bigger, so it does take that a little bit longer. But again, 10 HDs in 35 seconds probably isn't too bad. And again, if you then wish to extract information, just the parentage information, that can be done as well, picking that option. And typically 100 parentage SNPs takes about 5 seconds to extract. And those files are all generated and loaded to the FTP site as part of that process. So basically, thank you very much. And if anyone has any questions.